So we start with gravitation. Come. That's your unit number 3, your third unit of physics. Okay, very preliminary part is there, numerical oriented chapter. Little rest of the part is all theory. There are 2 numerical parts out here, but the major part of this chapter has been taken back to grade 11 now. So let's start with gravitation. All you are going to talk about here with 2 perspectives, we will be discussing this chapter. Settled? One would be, you need to have your concept correct on 2 perspective. One would be universe perspective, and one would be when you talk only about the earth. Okay, so when we talk about the universe, then it's the entire universe, where earth is also one body. And the other part, that as we will be discussing parameters and aspect about this chapter, we'll be talking about from the universe perspective as well as from the earth's perspective. Okay, so first let us understand gravitation. So as you all know that the entire story of Newton starts with he observing an apple falling from the tree. Earth attracts everything towards itself. So it all started from there, that earth attracts towards itself. If you see raindrops, why do raindrops fall? Why do raindrops not fly away? Raindrops fall to the ground, rivers flow, or else you throw everything, the atmosphere is held, the atmosphere does not get escaped away. So there is some force which is pulling everything towards the earth, right? If we drop anything from the top, the item does not stay there, the item actually comes down. Now that is called the force of gravity. And till now, when you are talking about all these things, earth, you have something called force of gravity. Now pay utmost attention to the terms. When you talk about force of gravity, you are talking only in terms of earth's attraction. Okay, force of gravity. So I can write it as force by which earth pulls every object towards its center. Okay, I'm just trying to build up your concept. This is called force of gravity. It is the force with which earth pulls anything towards this object, because at the beginning of the chapter when we study, you are basically on earth and you see things attracted towards the center of the earth, things start falling. This can also be called as earth's gravitational force. Very good. It's called the earth's gravitational force. Okay, now mind this word gravitational. Now this is a universal commodity. क्या हुआ बेटा, तुम इतना पहले आके क्यों सेटल नहीं हो पाते हो? You came, I think, just after Neha. You imagine you put yourself here and somebody toddling in front of you, then how much disturbed I feel. To teach also you need a flow to come, right? Had you come late like him, then it's a different story. You have come early. So what stops you from opening your book, your pen, your pencil and all? You have done all loitering in the house apart from getting ready for the studies. My dear child, it disturbs the flow of the person who is teaching. It disturbs me. Okay. So it's now, imagine, look at the word, see, this flow goes away. And you are not only causing problem to me, the rest and the ones online. Please don't do like that. This is a word gravitational again. Watch, gravitational. Gravitational is a universal commodity, right? Commodity means right now understand it's a universal concept. When you are assigning it specifically for the earth, that's why I used adjective. Kaunsa? Earth's gravitational force. ये gravitational force is a universal concept. दुनिया नहीं, पूरे ब्रह्मांड में है, universal. ठीक है, it's on the entire creation. I'm talking in terms of earth. So when earth pulls anything towards itself, we will call it the force of gravity. यहाँ पे अर्थ नहीं लगाने से भी चलता है. Force of gravity means the typical force which earth is pulling object towards itself. This concept many people are still not clear. Gravity, gravitation. And when you talk about the universe, then I would be talking about something called universal gravitational force. Universal gravitational force. Now, this force acts on any two bodies, and let me be very, comical in the way that I'll speak. It can act between two ants, two between Uranus and Neptune, two between Earth and Moon, two between you and me. Whether the force is, whether the force is of substantial value or not, that's a different thing. Everyone, has a bit of honesty and dishonesty in itself. Honest person's dishonest component is less, honest component is more, right? So you have to observe it like this. This is universal gravitational force. It's a universal concept. Universal means whatever you can think about the creation, it exists, and it acts on any two bodies. Now the question may arise, let's be very, very first humorous. Let's say we have an elephant, okay, and we also have a duck. Okay, a question arises, is there a gravitational force between these two? Yes, there is a gravitational force between these two. Okay, then comes the next question, that there is a duck and there is the moon shining bright. Okay, this is the moon, not the earth. This is the moon. Is there a gravitational force between them? Yes, there is a gravitational force between them. Yes, a satellite and earth, and that's being held because of the gravitational force. These are all universal concepts. I have included the moon. Why I have included the moon? Because these people are not available on moon, right? They are available on earth. Right? They are on planet earth. Pehle concept clear karo. They are on earth. So next question is, sir, between them, do we have gravitational force? Yes, we have. Again, we may have, say we have INSAT. These are our satellites. INSAT, say 1C, our satellite INSAT 1C. Do we have a gravitational force? Yes. Now do you understand? Universal gravitational force is the force of attraction that acts on any two bodies in this universe. Any two bodies in the universe. Hold your question 1 minute. Any two bodies. But when you bring your concept and you think from here, okay, from Earth's perspective, okay, from Earth's perspective, now you are inside Earth, you are the judge. Earlier you were here, somewhere at Uranus or Neptune, and you are watching, oh, Hati bhi khich raha hai, ye bhi khich raha hai, ye bhi khich raha hai. All these are universal. Now you are in Earth and you see that this elephant is getting pulled towards Earth. The ducky is getting pulled towards Earth. Then actually what are you referring to? You are referring to, again see, they are also part of universe. A person who is seeing it from Neptune might be seeing, oh, duck is getting attracted to Earth. So this is also a universal gravitational force. But we stay on Earth, so we study it separately, and we will say that this is Earth's gravitational force. Similarly, on Moon also there is gravitational force. Otherwise, Neil Armstrong could not have been standing on Moon. He should have got lifted. Maybe the gravitational force of Moon may be weak or strong. That's a different part. But they also have a gravitational force. Every body will have. And you can also call it as the force of gravity. Because when you're thinking from the Earth's perspective. Now, last one explanation, then Aditya, your question. I am on Venus and I watch that a boy is playing on Earth and he tosses the ball above and the ball gets attracted towards the Earth. I am watching it from Venus. So I say, oh, there is a gravitational force between the ball and the Earth. I don't know who is the owner of the ball. Universal gravitational force. It is happening in universe. The event is happening in universe. Same time, our friend Zoe is on her balcony sitting, watches that the boy is tossing the ball and it's coming to. She says, oh, look, Earth pulls everything towards itself. Because she is seeing it from Earth's perspective. So she says, this is a gravitational force. And me from Neptune, I also say this is gravitational force. She makes a better comment. She says, it's Earth's gravitational force.
Everything that's Earth's gravitational force is also universal.
It's also universal. Concept is like that. You are selfish because you are inside the Earth. You think everything is inside the Earth. But the person standing on Neptune does not have any difference between a duck and a Mercury and a duck and an Earth.
So it's just universal.
It's universal. So, but when we talk from the perspective of Earth, we say everything has force of gravity. ये ग्रेविटी वर्ड सुनते ही अर्थ अर्थ अर्थ, ग्रेविटेशन सुनते ही you are judging the same thing. This is from the high court perspective, this is from the supreme court's perspective, but you are judging a case only. First round of discussion, I know this is very high level. Ask questions that will clarify more. Yeah, first his question, he was on yeah.
So if we're like independent of other bodies, it's like, for example, this pen is here and it's like a complete vacuum. So this pen will be attracted.
Yeah, this pen, there is an attraction towards you. We will see
So it's
that
not
also.
orbiting.
Yeah, it should. No, orbiting you and all is a different part. Or the orbiting part is different. For orbiting, you have to have a velocity also. Something has to have a velocity, then the orbiting thing will start. You are getting attracted. See, if you get attracted, it should come and hit you straight away.
So this would also attract me in.
Yeah, there is an attraction. We'll keep that question in pending. Why like that? Let's make it more funny. You see a beautiful girl in your school every day. You have a doubt whether that girl is attracted to me. You are attracted. So before actually giving that proposal letter and getting rejection, you will take help of this chapter to first assess how much is the force. तब ना letter दो, वरना तो let's be friends now. तो गया तुम्हारा केस. तो उसको देखेंगे हम लोग. We will see that case also. ठीक है? That question of pen, this, that. Yeah, next question. But your question is absolutely valid. We will check that also. Yeah.
So like for example, we have satellites, right? So will they still be in like the Earth's gravitational force?
They are on Earth's gravitational force. Right now, Chandrayaan 3 has released the first set of pictures of moon. So why are we taking so much time to reach the Chandrayaan as compared to Neil Armstrong, who went within 36 hours? Our projects are all low-cost projects. Do you all know these things? Like the cost of, do you know the Mars mission cost? Mars mission cost, the highest cost has been from NASA. It is more than huge cost. After then comes Russian Cosmos, huge cost. India's Mars cost per kilometer is less than the Uber auto ride kilometer. Per kilometer cost, and it is less than a Hollywood movie. And you people are not told about these good things. That's why watch the movie Mission Mangal. There the lady explains it very nicely. What she does is that she starts making puri and her cylinders are over. And she says, once the oil is hot, you need not, the puri needs a particular temperature. Cylinder लगाने की क्या ज़रूरत है? वो गरम तेल में और 5 पूरी हो जाएगा. So how we are releasing our Chandrayaan? It is first on the Earth's orbit, then on. So do you know the principle how a rocket goes? First there will be the booster rockets जो fire करता है. Okay, the B-10 booster rockets will fire, and then the booster rockets will disengage. After that the rocket goes, and then the liquid propulsion will start. So it will orbit the Earth. Okay, and then last में the solid fuel will be there. So सब खुल जाएगा. Then you will be in this much portion. That will actually throw you from the Earth's trajectory to the Moon's trajectory. She is also pulling and I am also pulling. We are two sweet vendors, and the kid is roaming here. So how do we make? First the kid will come whoever has a tasty candy. So but the kid is around me. My candy is more tasty, but we wanted to go to her. Then suddenly we'll give one push, and I'm at such a place now, he can't see this candy anymore. He wants candy now. He will be encircling her. So the moon our satellite has now entered the moon's orbit, and on August 26 or 28 is the 23rd is the touchdown. Okay? So that's the touchdown. All these.
Even moon is a part of Earth's gravity.
Yeah, moon. That's the Earth's gravitational force. There's a moon's gravitational force also. If the moon's gravitational force was not there, high tide and low tide. How many of you have visited Mumbai's Haji Ali Dargah? Have you seen the Worldly Sea face? If you see the Worldly Sea face, then there is Mahalakshmi temple and a mosque, Dargah, known as Haji Ali Dargah. A lot of Bollywood shootings take place. So Haji Ali Dargah is a walk on the sea. But if it is a high tide, if you go to the Dargah, you can't come back. वो पूरा पानी के नीचे चला जाएगा. So how is the water rising? It's the moon which pulls. That's why full moon night. Like earlier in my job, when we used to release things from port, the release happens always on high tide. High tide, the port has a lot of water. It's easy to roll out the barge. So समझ में आया थोड़ा सा concept. What is universal? So gravitational force is there between any two bodies, whether we are on Earth or we are anywhere. As long as we are on Earth, we study it with little bit more love because we are selfish. We stay on Earth, so we call it force of gravity. Earth's gravitational force. ऐसे टेस्ट हमको भी है, whale को भी है ना. Whale must be also tasting. Crocodile also taste. Today's turkey was not that sweet. Masala was less. वो भी तो टेस्ट करता होगा, लेकिन हम लोग इसको इतना क्लियर हुआ. हाँ बोलिए.
But how? But there's also a thing that moon revolves around so it is
Every celestial body has two motion. There's a rotation on its axis and a revolution on the orbit. There are two motions always there. ठीक है? Rotation around it will cause you day and night. Revolutions cause seasons. ठीक है? इतना क्लियर हुआ. So now do you understand what is a gravitational force? A gravitational force is always an attractive force. This you learnt in grade 8, contact, non-contact force. So if you go back to grade 8, then we would call this force as a non-contactual force, non-contact. And this is always an attractive force. Whereas if you see electrostatic force, magnetic force, they can be attractive as well as repulsive. ये question आ जाता है true or false में. Gravitational force is always an attractive force. Whereas if you see electrostatic and magnetic forces, there can be attraction, there can be repulsion. Gravitation में attraction होता है. So a gravitational force is a non-contact attractive force which exists in universe between any two bodies, irrespective of where they are. Now whether the force is big enough or small, that will be Aditya's question, which we will answer in the next part. Force तो है, अब वो force substantial है नहीं है वो हम आगे देखेंगे. And since we are on Earth and majority of us in our lifetime will not be that lucky to go to Uranus, Neptune and Pluto, we will be seeing all the attractions versus Earth versus some body or body versus another body. That is the curious case of Aditya and girlfriend, that we will see body versus body and then we will see Earth versus body. ठीक है, clear इतना. चले आगे. ठीक है, आ जाइए. So our next part of the study would be concentrating. Now we will forget Earth for some time. भूल जाओ Earth को. And we will only study universal gravitational force. And इसको study करने के लिए यहाँ पे आ जाएगा Newton's law of gravitation, Newton's universal law of gravitation rather.
how many laws are there?
एक ही लॉ है बेटा, तुम्हारे लिए एक ही बना है इसमें.
No, it's like yeah.
इसमें एक ही लॉ है.
No, not in this chapter.
हाँ.
Across all chapters.
ओ न्यूटन्स लॉ ऑफ कूलिंग है, न्यूटन्स लॉ ऑफ हीटिंग है, सब जगह है. ठीक है, ठीक है. न्यूटन्स लॉ ऑफ यूनिवर्सल लॉ ऑफ ग्रेविटेशन. ठीक है, इसको समझते हैं, बढ़िया इंटरेस्टिंग है. इसमें कुछ दीज आर नॉट दैट टफ लाइक conceptually that tough like what we did in the case of laws of motion. ठीक है, are we ready? Okay. Now say suppose, however these laws are always applicable for point masses. अभी हम ऐसे समझेंगे. Okay, suppose we have two bodies. Okay, this is body 1 and this is body 2. Body 1, body 2. ठीक है, समझ में आया? This is actually the distance of separation of their centers. यहाँ पे center है. Okay. इस body का mass is m1. Zoe, you do keep an eye on your watch, okay? Once you did not ask me. And this body has a mass which is equal to m2. Understood? Two bodies of mass m1 and m2. And center to center, they are separated by a distance r. Understood? Center to center, they are separated by a distance r. Newton says that every body, first listen, every body in this universe attracts every other body. Right? Let's first every other body. So ऐसा देखे तो every body in this universe attracts every other body. Every body in this universe attracts every other body. ऐसा नहीं कि ये भी खींचेगा, ये भी खींचेगा, ये भी खींचेगा. Right now there are so many bodies in the universe. To make our system simple, we are just segregated two bodies. To understand it between first two bodies. यहीं पे देख लो ना कितने bodies हो, मैं, तुम, ये 10 लोग तो. Me no, there is attraction between me and her. her and him, her and you and me, there is all. Every body in this universe attracts every other body. I can't have so many bodies right now. So we have put it into two bodies. So at first we will see it from the perspective of this particular body. So this body will be attracting this particular body, right? खींचो इसको, खींचते हैं ऐसे, और इसको बोल देते हैं force attracted on 2 by 1, F21. Force on 2 due to 1. समझ में आ रहा है? क्या नहीं समझ में आ रहा है? बोल रहा हूं ना, सुनते नहीं हो ना? Force on 2 due to 1.
Body due to body.
अभी समझ में आया? To make the study easy, I am saying that this body is attracting this body, but in reality this body will also attract this body, because ये भी तो एक body है. Every body. तुम लोग लिखना छोड़ो, पहले समझो चीज को. लिखने से वो तो किताब में सब डेफिनेशंस है, यहां आते हो समझने के लिए, पहले समझो, नहीं तो मजा नहीं आएगा. ओके अब मैं बार बार बोल रहा हूं, दिस बॉडी अट्रैक्ट्स दिस बॉडी. व्हाई आर यू ऑल हैविंग सो सरप्राइजिंग फेसेस? लास्ट चैप्टर व्हाट डिड यू स्टडी? Newton's third law. It says when a body exerts a force on another body, the other body exerts an equal and opposite force on the first body. So what? So this will also should attract F. There should be an F12 where F21 and F12 are just opposite to each other, equal in magnitude. So right now we are not bothered on that F21, that I am not saying. Okay, if you want, I can draw that also. अगर आपको चाहिए तो इधर एक और फोर्स आएगा, and that force will be F12. Okay, this will be F12, which I'll say force exerted on body 1 by body 2. ठीक है?
So F12 will be equal to negative of F1.
Negative because directions are opposite, na? Magnitude of F12 will always be equal to magnitude of F21. This is Newton's third law. However, if I write it in a vector equation, then I will write F12 as a vector is negative of F21. Means माइनस का मतलब कम नहीं है. ये अगर लेफ्ट से राइट खींच रहा है तो वो राइट से लेफ्ट खींच रहा है. Yes, absolutely correct what she said. That's the thing. It's reverse. Understood? So right now, since these two forces are equal in magnitude, I'm just replacing them for understanding as a force F. This is the force F, which is the gravitational force of attraction, right? If I find F, I can say agar this is positive, that is negative, as simple as that. I just need to know now what is that F. ठीक है? Clear है ना? अब हम F को define करेंगे. Newton says that in his law of gravitation, he defines this law into two parts. The first part says, okay, before that, 8th में तो पढ़ चुके हो, direct variation. You know what is direct variation? If one quantity increases, another. He says that this force is directly proportional to the product of masses of two bodies. अगर ये प्रोडक्ट बड़ा होगा तो ये फोर्स भी बड़ा होगा. जुपिटर एंड सन बहुत बड़े बड़े हैं तो उनका ये फोर्स भी बड़ा बड़ा होगा. मास ऑफ जुपिटर इज बिग, मास ऑफ अर्थ सन इज बिग, तो इनके बीच फोर्स भी बड़ा होगा. ठीक है? एंड देन यू विल कम अक्रॉस दिस पार्ट, which अभी थोड़ा ध्यान दे के इसको देख लो. ये 11 वगैरह में बार बार पढ़ोगे. दिस कॉल्ड द इनवर्स स्क्वायर लॉ. इट सेज this force will be inversely proportional to the square of the distance between them. Mind you, square of the distance, this you will learn in electricity also later on. This is called a very famous law called inverse square law. Means जितनी इनमें दूरी बढ़ेंगी वो फोर्स कम होता जाएगा. कोई नई बात नहीं है. If you stay far away from somebody, is there any force? कोई फोर्स नहीं है. मैग्नेट भी अगर दूर दूर रखोगे तो नहीं फोर्स है. चार्ज में भी दूर दूर रखेंगे तो दिस इज कॉल्ड, बट it is not related to r, square of r. So if you are far apart, and then if you are far apart, r is big. If r is big, then square of r is even bigger. So the force will come down because force is inversely proportional. ये denominator if it increases, ये क्वेश्चन घटेगा ना, समझ में आया?
Yes.
अब हम क्या करते हैं, इन दोनों स्टेटमेंट्स को क्लब करते हैं. We will write everything. First understand the clubbing. Force is directly proportional to product of the masses and inversely proportional to the square of distance between them. यहां से ये समझ में आया, दोनों को क्लब कर दिया. ठीक है? Whenever you have what you call proportionality, you have to introduce something called constant of proportionality. Like force is directly proportional to m, force is directly proportional to a, force is proportional to m into a, so force is equal to kma. तो k का वैल्यू 1 आता था, तो यहां पे आ जाएगा अभी k, अब नया कुछ आएगा, दिस इज कॉल्ड g. ये सब ध्यान से देखना, ये कैपिटल G है, इसको कभी स्मॉल g मत लिखना, लड्डू मिलेंगे पूरे मोतीचूर के. ठीक है? g m1 m2 by r square. अब g का कुछ नाम भी होना चाहिए. यूनिवर्सल ग्रेविटेशनल कांस्टेंट, यूनिवर्सल ग्रेविटेशनल कांस्टेंट, बहुत एब्जॉर्ब कर रहे हो इसलिए आई विल स्टॉप, वी विल रिवाइज. ग्रेविटेशनल कांस्टेंट एंड दिस इज इक्वल्स टू, बाद में रट्टू तोता मत बनो, पहले ये समझो. इसका ये दुनिया भर नहीं, पूरे ब्रह्मांड में लागू है, पूरे यूनिवर्स में लागू है. इट्स नॉट ओनली हियर, it's not only Uranus, Neptune, Pluto. You are in a very small system called solar system. Get out of it. Then you are in Milky Way. Get out of Milky Way. You are one part among so many galaxies. It is applicable for anywhere. And the value of this was calculated by Cavendish. वो आपके सिलेबस में नहीं है. CAVENDISH. Cavendish ने इसका वैल्यू दिया था. तो पूरी चीज को एक बार रिवाइज करते हैं. If you have now, since this is a gravitational, हम लोग यहाँ पे हाथी, बतख, all these we have seen. Now we replace them with our physics, our favorite drawing, body and body, mass and mass. There should be a law, a force of attraction between. This is always an attractive force. So Newton's universal law of gravitation says, you will write, don't worry, suno pehle, every body in this universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. And one more thing, how does this force act? It acts on the line joining the center of two bodies. ऐसा नहीं कि यहां से फोर्स वहां जा रहा है, ऐसा नहीं होता है. That's why I have drawn the force on this center line. तो हमें तीन चीज यहां क्लियर होना चाहिए. बॉडी का सेंटर टू सेंटर डिस्टेंस. Even in engineering drawing, when we say, the wheel to wheel distance, rear wheel and front wheel, it will be always center to center distance. Okay, so we will call it. So we call it a center to center distance between the two wheels. So center to center distance and center to center. So this force of attraction means if this body, pulls it along the center line. If this body, pulls it along the center line. Every body, ये भी attracts every other body. इसके लिए ये. मेरे पासा. With a force that is directly proportional to product of the masses, inversely proportional. If we combine these two, we get F is directly proportional to m1 m2 by r square. So F is equal to g m1 m2 by r square. This force is known as gravitational force, and the constant is known as universal gravitational constant. इतना समझ में आया? कुछ भी लिखना है लिखिए, फिर और बातें करेंगे इसमें. Yes sir. R is the distance of separation between the two bodies measured from center to center.
R is basically distance.
R is the distance between the two bodies, and the distance is always taken center to center because we are now taking some spherical bodies just for our understanding. So you can write like this. Every Newton's law of gravitation states that every body in this universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. हाँ, इसको देखिए आप कर सकते हैं, मैं याद थोड़ी है. देखते देखो आप बोलो एवरीबॉडी, देखो डायग्राम है, आप अपने लैंग्वेज में लिख लीजिए. हर एक बॉडी पृथ्वी नहीं, इस ब्रह्मांड में हर एक बॉडी एक दूसरे बॉडी को एक आकर्षक फोर्स से खींचता है, जिसकी वैल्यू होती है डायरेक्टली प्रोपोर्शनल. किसमें? उनके मास के प्रोडक्ट के साथ, और इनवर्सली प्रोपोर्शनल स्क्वायर ऑफ द डिस्टेंस।
Sum of the masses.
प्रोडक्ट,
Multiplication.
एक और चश्मा ले लेना, मेरा वाला भी इधर प्लस प्रोडक्ट नहीं दिख रहा है। एंड इनवर्सली प्रोपोर्शनल टू द स्क्वायर ऑफ द डिस्टेंस बिटवीन देम। दोनों को मैंने कंबाइन किया, ऐसे लिखा, और अगर मैं इक्वल टू डालूंगा तो मुझे कांस्टेंट ऑफ प्रोपोर्शनलिटी लगाना पड़ेगा। लगाया।
Sir,
बोलिए
each
सर।
body in this universe will have different forces of attraction.
फॉर अनदर बॉडी, अब सोचो तुम और ट्यूबलाइट, ये फोर्स कितना होगा? तुम्हारा मास इंटू ट्यूबलाइट का मास। तुम और भैंसा, तुम्हारा फोर्स और भैंसे का मास मल्टीप्लाई होगा ना, तो फोर्स का वैल्यू तक हो जाएगा। इसी डिस्टेंस में ट्यूबलाइट रखो, इसी डिस्टेंस में भैंसा रखो, तो फोर्स कितना है? जी श्रेयस ट्यूबलाइट डिवाइडेड बाय आर स्क्वायर। और अभी क्या होगा? जी श्रेयस भैंसा डिवाइडेड बाय आर स्क्वायर। दोनों का वैल्यू सेम होगा क्या? नहीं ना। और यहां भैंसे से चंपाकली को रख लो तो फोर्स अलग आएगा। जाएगा तुम्हें समझ में? ठीक है, आया बात समझ में? Yes, Sanvi, Aparna and Sudhriti. Sanvi, Aparna, Sudhriti. SAS. Congruence. SAS. Okay, Sanvi, Aparna, Sudhriti. बैठा भी वैसे ही ऐसी, one side Sanvi, बीच में Sudhriti, then Sanvi, Aparna, Sudhriti. एकदम SAS. और बीच में मैं घुस गया, CPCT. Means सबको समझ में आना पड़ेगा. Have any queries, Bittu? 3 of you who are Sanvi must be seeing now pigeons of Abu Dhabi. They look the same like us, Pebble City pigeons, always hungry.
Sir, it's probably too hot for that. It's probably going to
If there is no pigeon,
Obviously, there will be pigeons, but like,
Is it 40?
and what is the temperature now?
it's 40
40? 41. सोचो,
Isn't it like
41 मीन्स ग्लास में ऑमलेट का घोल लेके डालो, इमीडिएटली ऑमलेट हो जाएगा। ठीक है, आगे बढ़े। Shall we go ahead? Any more queries from here? No queries? ठीक है, आगे बढ़ते हैं। थोड़ा मिटाओ, कैन आई? ओके, यस सर।
ये यूनिवर्सल ग्रेविटेशन कांस्टेंट का भी कोई वैल्यू होगा?
हाँ होएगा ना, अभी रुको ना बाबा, तुम पिक्चर हॉल में घुस के पहले ही लास्ट सीन देखने का कोशिश करेगा क्या? इट इज अ मूवी, इट्स नॉट यूट्यूब दैट यू विल गो ऑन ड्रैगिंग। हाँ दिखाओ दिखाओ दिखाओ, वो वाला सीन दिखाओ, ऐसा थोड़ी है। तो प्रति जी को बड़ा मजा आ रहा है, हाँ बहुत हंस रही है आजकल। प्रति जी टाइम पे आती है। हाँ प्रति जी, क्या हो गया? घर के घड़ियां गलत वक्त दे रही है क्या? बड़े जल्दी आ जाते हो आजकल। हाँ, वो इम्पल्स काम कर गया है, डोज। चलिए, ग्रेविटेशन में नाउ वी आर टॉकिंग अबाउट न्यूटन्स लॉ ऑफ ग्रेविटेशन। ठीक है ना, यही तो हम पढ़ रहे हैं अभी। आ जाओ, एंड वी आर नाउ इनटू द मैथमेटिकल पार्ट। वी से F is equal to G m1 m2 upon r square. ठीक है, now look at here, there will be a value of G, no doubt about it. Can we first find what is the unit of G? G का unit क्या होगा? Let's first see. So you keep G on one side, let's keep G on one side, then this becomes what? F r square divided by m1 m2. Isn't this not G? Yes, this is G. So let's find out first the unit of G. Why I'm showing it this way, so that you don't ratify मत करो, मजा नहीं आएगा। उसका यूनिट देखो, F is what? Newton, R is meter square, this is kg square. Okay, let's break it further. Newton बोले तो mass into acceleration, kg meter per second square into meter square, whole thing divided by kg square, means into 1 by kg square. Now we need to do kata-katis, and then this becomes meter cube second minus 2 kg minus 1. Either you can leave it like this, और एट योर लेवल यू कैन लीव इट लाइक दिस ऑल्सो, न्यूटन मीटर स्क्वायर kg -2, इसी पे छोड़ दो। और भी जाना चाहते थे तो ऐसे भी जा सकते हो। एंड इन ग्रेड 12 11 वी विल डू डायमेंशन एनालिसिस भी, आप वो भी कर सकते थे। डायमेंशन एनालिसिस लाइक व्हाट इज दिस इज लेंथ, दिस इज टाइम एंड दिस इज दिस, ठीक है। हैव यू अंडरस्टूड? सो लेट्स फर्स्ट राइट डाउन द यूनिट ऑफ इट। सो द यूनिट ऑफ इट वुड बी न्यूटन मीटर स्क्वायर पर kg स्क्वायर, kg -2। इसकी वैल्यू होती है 6.67 इंटू 10 to the power -11। 6.67 into 10 to the power -11। Then we'll do some numericals also, ठीक है। पहले ये लिखिए 6.67, and your book is using, let me see, they are using 6.67 or 6.7, they are using 6.7, they made your life a little bit more easier, so let me also do that। 6.667 मतलब they are using it at 2 figures। एक मिनट बिट्टू, just एक मिनट, हाँ just 1 minute, आप 6.7 करके चलिए। 6.7 into 10 to the power -11, just 1 minute, हाँ, न्यूटन मीटर स्क्वायर पर kg स्क्वायर। या बिट्टू बोलो क्या बोलना है, बोलिए। That is a different thing, बोला ना, this is not YouTube, either control is not in your hand, watch the stories according as they are coming। Now how do we define this g? We should also be able to define g, और g को define करते हैं। f is equal to, g की वैल्यू डाल दो 6.67 into 10 to the power -11, right? And let's put its unit Newton मीटर स्क्वायर divided by kg स्क्वायर, ठीक है। जस्ट सी द ब्यूटी ऑफ फिजिक्स यहाँ पे, g m1 m2। नाउ वी नीड टू डिफाइन दिस एंड आई एम राइटिंग m1 m2 by r square। so I should be able to write a kg square here also, sorry, a kg square for this and a meter square for this। I have a reason why I have written this, I have written the units of everything, and f is in Newton, right? So many newtons, ठीक है। कॉपी मत करो, देखो, assume that you have a body of mass 1 kg, assume the other body is also a mass n 1 kg and they are separated by a distance of 1 meter, ठीक है। अब डेफिनेशन कैसा हो जाता है देखो तो, f is equal to 6.67 इंटू 10 to the power -11, kg स्क्वायर को काट दिया, मीटर स्क्वायर को काट दिया, ठीक है, और कुछ नहीं रहा। तो इस साइड में भी f इज मेजर्ड इन न्यूटन, ये भी न्यूटन में आ गया हमारा, सिंपल। और इफ यू वांट यू कैन और you leave this, so many newtons। Are you now able to define what is g? Can you now define what is g? G is the force of attraction that exists between two bodies of mass 1 kg separated by a distance of 1 meter। In that case the F is equal to G। see, ये दिमाग में आ रहा है? F becomes equal to G only when, look at this, F becomes equal to G if this m1 m2 and r square, if this m1 m2 and r square everything becomes 1। So we made it 1, let the body, first body be of mass 1 kg, let the other body be of mass 1 kg, let them be separated by a distance of 1 meter, then the force of attraction which exists between these two bodies। शायद आपको अभी भी समझ में नहीं आ रहा है, तो let's go to the vegetable market on Saturday and take 2 1 kg, ये 1 kgs है, those trivial weights which we have, understood? Vegetable market, separate them between how much? 1 meter we can do, then there is a force of attraction between them, very less, see, 10 to the power -11, बहुत कम है बहुत कम है। There is a shop near your house called बालाजी पापालाल, ग्लेंडेल घुसने से पहले, उसमें समोसे बनते हैं ना, क्या उसकी खुशबू यहां तक आ रही? आ तो रही है। Our nostrils are not able to smell that, it's not that strong here। भाई बाजू वाले घर में समोसा होगा तो सूंघ सकते हैं ना, इसका आर कम है मेरे साथ, वो आर ज्यादा है, पर ये नहीं कह सकते कि उसकी स्मेल नहीं आ रही है, आ रही है, तुम सूंघ नहीं पा रहे हो। वहीं अगर एक डॉग है ना, वो यहीं से उधर के आदमी को सूंघ लेगा। क्या हुआ? हाँ, तो पानी इधर भरने गए हो, बाजू वाले घर में भरने गए हो, कब से भरने गए हो? 3 बोतल पानी है यहाँ पे। हाँ तो ठीक है, हैव यू अंडरस्टूड दिस? F, now how do we define the universal gravitational force? We say G is that value of force which exists between two bodies of unit mass separated by a unit distance. If two bodies of unit mass means 1 kg, if there are two bodies whose mass is 1 kg and you separate them with a distance of 1 meter, then the force of attraction which exists between them will have a value of 6.7 into 10 to the power minus 11 Newton. Very less. Now I got my scientific calculator also. So we need to do our lovely calculation. So let's have Aditya here. ठीक है ना? क्या भाई कितना होगा बॉडी मास तुम्हारा? बोलो कितना? 20? कितना? 50? हाँ? 200 watt. kg, how many kgs is your?
50 some 53
55 kg, ठीक है। और इधर तुम्हारा क्रश कितना डालें इसको? लड़की है ना तो इसको कितना करें? 39, आजकल की लड़की है 39, ये भी वर्कआउट वगैरह करती है, ठीक है। और तुम इसको रोज अपने क्लास से देखते हो, कितना दूर में देखते होगे? 10 मीटर रफली। आओ देखते हैं और विच अट्रैक्शन है कि नहीं। चलो निकालते हैं। F is equal to 6.67 10 to the power minus 11 multiplied by 55 into 39 divided by 10 square। ठीक है, कहाँ गया साइंटिफिक कैलकुलेटर? हाँ लेट्स, तुम्हारा आजमात है तुम्हारी किस्मत, ठीक है। देखो 55 kgs into how much? 39 divided by how much? 10 square is 100, this much multiplied by 6.7, exponent कितना? negative 11, 6.67. अच्छा, I have got that habit of writing 6.67, you write 6.7, okay, 10 to the power minus 11. So the magic figure comes out and I'm writing it. The attraction force between you and your crush is around 1.44 into 10 to the power minus 9 Newton. बहुत कम है। ये क्या है पता है ना? Now if you give a letter, वो फूल मारेगा पर गमले के साथ मार देगा।
Sir, what if instead of 10 meter you keep it as 5 meter?
5 meter, then you know na, there is something called, when we talk to people, now very nice question. When you talk to people, then there is something, a very nice question you asked. When we go for the soft skill training, we say there's a personal space. You know what is personal space? So like you have eaten a lot of biryani with chewed lot of onions, then an onion a day keeps everyone away, right? Nobody can stand in front of you, you can't talk because, okay. Now onion खा लिया तुम बिरयानी खाने। So there's something when we talk to people, there are some people, these are good manners and habits. Very nice question. Imagine this tube light is a person, then you go and talk, hey, how are you? Hello, how are you? So that's called barging into the personal space. So we have got 3 space out here. That's not 5 meters. So understand that 5 meters. I wanted to talk this because you all are growing up now. Okay, you should understand like what is present, how you should conduct yourself. There is something called personal space. Anything that is around at least 20 inches from me. 12 inches is a scale. 8 meter दूरी पे, that's personal space. Once you cross the personal space, it's called your intimate zone. You don't come there. You talk from the personal space respect, and after that is the public space. When you talk to people, one to many communication, right? अभी आप जो बोल रहे हो ना कि इसके डिस्टेंस को कम करके 5 मीटर में ले आओ, कर देते हैं 5 मीटर। चलो आपकी दिल की तमन्ना थी तो 5, ओके, एट 5 मीटर सेपरेशन, ठीक है ना? 5 मीटर सेपरेशन itself is dangerous, ठीक है, क्योंकि उसको डर हो जाएगा। तो करके देखते हैं, फिर भी आ जाओ। 55 into 39, पर वो चांटे के रेंज में भी है, लेकिन अभी 55 into 39 divided by 25, okay, and then you multiply it by 6.7, and that's exponent minus 11, right? So Kismat is very bad now also. 5.74 into 10 to the power minus 9 Newton. हाँ, तब वो जाएगा नहीं ना. Now he is asking a new question, which physics wise has got lot of value. Listen to this next question. Shreyas is saying, weight नहीं बेटा, mass, ठीक है? Mass बढ़ा दे तो physics wise he is correct, because now he is encashing on the numerator. Very nice. मास बढ़ा देगा फिर उसका अट्रैक्शन नहीं आएगा ना, तब तो वो मोटी दिखेगी उसको, ठीक है, वो भी एक सवाल है ना। हाँ, तो उसका मास बढ़ाओगे तो देन हमटी लव्स डम्टी, देन इट विल बी हमटी लव्स डम्टी। क्या चीज? तुम्हारा when your PCB of your brain was manufactured by God ना, some wire is wrongly connected, that's why you think tangential। जैसे पूरी बातचीत ऐसे हो रही है ना, then suddenly you have a thought process here, some wire is wrongly connected in your PCB है, manufactured defect हो तुम। No, reduce, then it will, yeah, please. If you reduce their masses, it will be more bad. Shaurya, see, if you reduce the mass, the numerator falls down. So this is a very nice question. Zoe, just pull the door. Yeah, she's done. So what happens here is that, close the door. What happens here is that if you want, someday the whole door will go away. Okay. So if I have to put a chain like this, do not cross transit. So yeah, the question that you said. Now, why I gave all these examples for you to understand is actually Newton's law of gravitation is applicable for point masses. We consider masses as point mass later on. ठीक है, ये तो बात हुई। In order to have this force, see, 1 Newton is a force which has some appreciable value. अगर आपको इसको पॉजिटिव में लेके जाना है ना, your masses should be very big. ठीक है, अब इसी चीज को ये मजाक के साथ साथ कुछ एक और कर लेते हैं। Let's take the mass of Earth. I know mass of Earth is around 6.4 into 10 to the power 24 kg. ये मुझे पता है। And distance between Moon and Earth is 3,84,000 kilometers. 3,84,000 kilometers. Okay. Shaurya, can you quickly Google and tell me the mass of the Moon from Google? पटाख से देख तो। Mass of Google. Moon, not mass of Google. Densities से। हाँ, mass of Moon roughly कितना है?
7.3476।
हाँ, 7.34 into
10 to the power 22.
10 to the power
22
kg. Now children, look at the data. When we were looking for this boy and girl, they were around 55. इसका मास देख रहे हो कितना है? 6.4, 24. इसका फोर्स कैलकुलेट करना। The moon is held on its orbit. तो जबरदस्त सब्सटेंशियल फोर्स होना चाहिए। अब इसके फोर्स को कैलकुलेट करते हैं। So the earth is around 6.4 into 10 to the power 24. The moon is around 7.3 into 10 to the power 22 into 6.7 10 to the power minus 11. That's the value of g divided by r square. So this many kilometers, okay, that means 3,84,000 kilometers means into 10 to the power 3 इतना मीटर, then इसका स्क्वायर। समझ में आ रहा है कि नहीं? देखो तो, this is kilometer. 3,84,000 kilometer is the distance from moon to earth.
10 to the power 3.
तो मीटर किया उसको और फिर इसका स्क्वायर किया, ठीक है? हाँ, no, you won't get questions like this. ऐसे questions नहीं देते हैं। आप उसका डर मत करो ना, आप प्रॉब्लम को एंजॉय करो ना। करते हैं, इसको देखते हैं। I also cannot do it. That's why I brought my calculator. Let's see this value. Okay, so we are around, हाँ, नहीं, हाँ, calculate. See here, you won't get problems of this type. Now let's see the value. प्रॉब्लम का मजा लो ना, तुम्हें बेकार की बातों में फंसे रहते हो, ठीक है? So it's 3,84,000. Okay, 3,84,000 into 1,000, that makes it meters. इसको मैंने स्क्वायर किया, then x to the power y minus 1 किया, इसको ऊपर उठा लिया। So this is this value multiplied by 6.4 exponent 24. Okay, so then multiplied by 7.3 exponent 22. This into 6.7 exponent negative 11. Look at the force. Now look at the force. 2.122 into 10 to the power 20 Newton. Huge force. Look at the distance of separation कितना है? 3,84,000 का तो भूतनी का तुम्हारा 10 मीटर में किस्मत नहीं जागा। इसका देखो 3,84,000 किलोमीटर में फोर्स क्या है? ताबड़तोड़ फोर्स है। हाँ, इसलिए तो बोला ना, ये हमारे तुम्हारे में वो एप्लीकेबल नहीं। That's why I gave that बालाजी पापालाल एग्जाम्पल। उसके समोसे की खुशबू तो यहाँ तक भी आ रही है, आप सूंघ नहीं पा रहे हो, but you can't say there is no force. There is a very light. That's why when we design everything on earth, ग्रेविटेशनल फोर्स को हम पकड़ते ही नहीं हैं, क्योंकि वो फोर्स बहुत कमजोर है। Now come to that next question again, which I used to ask every time, that you take a scale and start rubbing it on your head and put it on bits of papers, the papers get stuck, and then after looking all these things I ask you, that is electrostatic force. Is electrostatic force greater or gravitational force? Everybody by looking, when gravitation होगा ना, Uranus, Neptune, sir, gravity is more. मैं से you भूतनिका, is the gravity not pulling that paper down? Yes, still the scale is holding the papers. So which force is more? Electrostatic force. It's much higher. Electrostatic force. Later on you'll study that when you're able to hold like this and you are not skidding, this is also an electrostatic force only. ये भी आप 11 में पढ़ेंगे that all forces later on can be brought down into two type of forces, strong force, weak force. In fact, क्लासिफिकेशन ऑफ फोर्सेस को लेके देयर इज वन नोबेल प्राइज फ्रॉम पाकिस्तान, हैज वन नोबेल प्राइज ऑन, इसमें एक जेंटलमैन का है, he tried to conceptualize all forces as one force. ये आप जाके पढ़ेंगे जब, see you, if you have interest in cosmos and all, how did the universe originate, how were the forces built up, कैसे force electrostatic force हुआ. So are we clear on this part, that the law of gravitation and gravitational force makes sense only when you have lot of mass. Sir, our distance should be less? Not necessarily. The moon and earth, Chandrayaan आज भी नहीं पहुंचा है, पहुंच रहा है अभी धीरे धीरे. So distance is quite big, but yet the force is high because the mass plays a significant role among them. Have you understood? Any questions? Now can you define what is Newton's law of gravitation? If you read the book will say Newton's law of gravitation states that every force in this every body in this universe attracts every other body by a force which is directly proportional to the product of their masses, inversely proportional to the square of the distance between them. And there comes the universal gravitational constant, a value given by 6.7 into 10 to the power. Will you be able to find out this unit on your own in the exam? अगर आप फंस गए तो कैसे यूनिट को अपने आप निकालना चाहिए? ठीक है, तो देखते हैं कैसे. देखो यही सब तो सीखना चाहिए ना. ये देखो आपने, आप इसको कैसे निकाल सकते हो. सी दैट मीन्स तोता बन रहे हो. तोता नहीं बनना है, पहले सीखो. एक्सप्रेशन याद है, F इक्वल टू G m1 m2 बाई आर स्क्वायर. उल्टा पुल्टा कर दो, G m1 m2 बाई आर स्क्वायर इक्वल टू F. G को अकेला छोड़ दो, आर स्क्वायर F डिवाइडेड बाई m1 m2. बस अब सबका यूनिट डाल दो. आर स्क्वायर मीन्स मीटर स्क्वायर, F मीन्स न्यूटन, m1 m2 मीन्स kg स्क्वायर. अब सुंदर से लिख लो, न्यूटन मीटर स्क्वायर kg -2 हो गया. किसी भी चीज का निकाल सकते हैं. ओके, लेट्स सी फॉर मोर बेसिक. फोर्स इक्वल टू मास इनटू एक्सीलरेशन. भूल गया हम लोग एक्सीलरेशन का यूनिट क्या है. A इज इक्वल टू F अपॉन m. F इज इक्वल टू न्यूटन पर मीटर. ऐसा नहीं लगा, मैम ने तो ऐसा नहीं बताया था. चलो मैम की बात करें. न्यूटन इज इक्वल टू व्हाट? मास इनटू एक्सीलरेशन. kg मीटर पर सेकंड स्क्वायर डिवाइडेड बाय मीटर मींस 1 बाय मीटर. क्या हो गया? kg. एक्सीलरेशन इज इक्वल टू फोर्स बाय मास. व्हाट डिड आई राइट हियर? m. ये kg है ना, इस kg, ठीक है ना. फोर्स बाय मास, kg कट गया, आंसर आ गया मीटर पर सेकंड स्क्वायर. बात पा दो, कई को रटने का. Understand? You better understand. ठीक है, ठीक. आइए, अब इतना में टाइम हो गया यूनिवर्स को छोड़ने का और वापस अर्थ के अंदर आने का, है ना. क्योंकि यू आर ऑन अर्थ, तुमको तो बाद में सब वही चाहिए. हमारे स्कूल की वो लड़की, तो बाहर की लड़की पसंद ही नहीं है, क्या करना है ना. तो तुम्हें सिर्फ स्कूल की लड़की, तो स्कूल का लड़की देखो. अभी अर्थ पे आ जाओ वापस, कम डाउन. मूवी वूवी देख के अभी हो गया सब, है ना. घर में जाके तो वही देखना है, अपना ही कहानी, ठीक है. बहुत देर हीरोइन देखे, लाइफ क्या सेट था एकदम पूरा, वहाँ पे नाचा गाना वाना देख लिया. अगर मैं भी डांस करके जाऊं, और फिर घर पे आके क्या देगा भाई? वही सुबह वही कुत्ता घुमाने ले जाना है, वही काम करना है, कपड़ा प्रेस करना है, बस वो गाना गाते गाते अभी कपड़ा प्रेस करते रहना. आ जाओ लाइफ में. तो कोई कम बैक टू अर्थ नाउ. ठीक है, हम अर्थ पे वापस आ जाते हैं, ठीक है, और अर्थ में हम अभी यहां हैं, ट्याओ, समझ में आया। और अर्थ का रेडियस कितना है, अर्थ का रेडियस होता है, ये कुछ डेटा आप हमेशा याद रखो। अर्थ का रेडियस ऑफ अर्थ इज 6400 किलोमीटर। वैसे बुक में आपको प्रॉब्लम में दे देगा, याद रखने से कोई बड़ी बात नहीं, याद रख सकते हैं, ठीक है ना। जैसे उसका मोबाइल नंबर याद है, इसका ये याद है, इसका इंस्टा याद होता है, ठीक है। ये है रेडियस ऑफ अर्थ। ये अर्थ के रेडियस में रख दो एक छोटा सा 1 किलो मास। चिल्ड्रन online you all will curse me for drawing so small, at least Sudriti will. So let me, how do I draw that? Then the weight mass looks more bigger in size. So this is 1 kg mass. 1 kg mass is on the surface of the earth at a distance of how much? 6400 kilometers. From where? From the center of the earth. Okay? So let us see with what force earth is going to pull this 1 kg. Right? With what force earth is going to pull this 1 kg. ठीक है, तो क्या फॉर्मूला लगाएंगे, बोलो, यू टेल मी व्हाट शुड बी द फॉर्मूला। F इक्वल टू G m1 m2, बाजू में घर है, ठीक है। तो आज वैल्यू डालते हैं, जी का वैल्यू कितना है 6.7, 10 to the power -11. What is m1? Oh, mass of the earth also you should always know. Mass of earth is 6 into 10 to the power 24 kg. Okay, mass of earth. तो कितना हो गया, m1 is the earth, so shall I put 6.7 into 10 to the power -11. दूसरा वाला मास कितना है 1 kg. Oh, 24, sorry.
No use of writing.
24.
Sir, 0.7.
Okay, this is 6, sorry, 6.0. ठीक है, 1 kg divided by r square. So 6400 kilometers means into 10 to the power 3, so many meters square. ठीक है, इसको ऐसे ही करने की कोशिश करें, पहले इजी सिंपल में करते हैं, बिना कैलकुलेटर के देखते हैं। 6.7 into 6 into ऊपर कितना हो गया 10 to the power 11, 10 to the power 24. If you add them 24 और 10 करेंगे तो 10 to the power 34, 24 10 करेंगे तो आएगा 14, ये 11 है तो 13 आएगा, 10 to the power 13. अच्छा, नीचे क्या है, नीचे आएगा हमारा 6400 का स्क्वायर बनेगा इंटू 10 to the power 6 बनेगा, 3 into 2 is 6. ठीक है, और थोड़ा इजी करते हैं इसको, 64 into 64, 64 into 64, ऊपर है 6.7 into 6, इधर है 10 to the power 13, इधर कितना है 100 into 100 का स्क्वायर है, फिर से सी 60, ओ हाय, इसमें 100 है, इसमें भी 100 है, ठीक है, 100 into 100 का स्क्वायर है, डू गेट इट। सो 100 into 100 का स्क्वायर वो बाहर निकालना पड़ेगा आपको, सो एक 100 into another 100, you have another 100 into another 100, 64 into 64, okay, 6400, सॉरी एक ज्यादा हो गया, दो ज्यादा लिख दिया मैंने, so it will be this 6400, this is 6400, this is 6400, agreed। और एक 10 to the power 6 भी है आपके पास, चलो और सिंप्लीफाई करो इसको, 6.7 into 6, ठीक है, नीचे कितना हो गया 64 into 64, अब करो 10 to the power 13, how much is here 10 square और 8, यानी कितना होगा 10 to the power 10, ये स्क्वायर हो जाएगा, नहीं ये 10 स्क्वायर है, ये 10 स्क्वायर है, स्क्वायर स्क्वायर से हो गया 4, 4 के साथ 6 ऐड हुआ तो हो गया 10, और फाइनली ये कितना हो जाएगा 10 to the power 3, और इसको हम कर लेते हैं अपना छोटू मोटू कैलकुलेटर से, हर समय तुम्हें साइंटिफिक कैलकुलेटर की जरूरत नहीं है, तुम लोग खाली गोली मारते रहते हो ना, इसीलिए तुम्हारी लाइफ ऐसा है। 6.7 into 6 डिवाइडेड बाई 64, ओके, अगेन डिवाइडेड बाई 64, ठीक है, वैल्यू कितनी आई हमारी 9.81 into 10 to the power, नहीं, if you do only this much, then the value comes 9.81 into 10 to the power -3, got it, if you do only this much, सो यू हैव अनदर 3. अब तेरा 9.81 समझ में आ रहा है?
हाँ।
हाँ, तो इसके साथ तभी चिल्ला रहा था ना, एक और 10⁻³ बाहर का रह गया, जो इसने इसको काट दिया. 9.81 न्यूटन. नहीं, वो अलग चीज है. ये वो ऐश्वर्या नहीं जो ब्यूटी क्वीन है, ये हमारे कॉलोनी की ऐश्वर्या है. वो ब्यूटी क्वीन वाली थोड़ी और बाद आएगा. ये क्या बताता है? जस्ट लाइक यू नाउ फाउंड आउट व्हाट इज द फोर्स अर्थ इज एक्सर्टिंग ऑन द मून. थोड़ी देर पहले निकाला था, मून पे 10⁻20. दिस फोर्स इज what the earth is exerting on a body of mass 1 kg kept on its surface. Earth exerts a force. क्या रे हर किरत, तू आज इतना जल्दी घड़ी वड़ी खराब हो गया घर में? फोर्स ऑफ, अच्छा आ जाया करो, अच्छी बात है. 9.81 न्यूटन on a body of mass 1 kg kept on its surface. और ये जो kept on its surface लिख रहा हूं ना, kept on its surface, इसका मतलब है when the r is 6400 kilometers, that is the radius. Now the good thing that you should ask me, sir, ma'am had told the earth is not round, it's flattened at the pole like an orange. ऐसा है ना अर्थ? यानी कि यहाँ पे जो रेडियस होगा, रेडियस as measured from pole to radius as measured from equator, कौन सा रेडियस ज्यादा होगा? इक्वेटर ज्यादा होगा. RE is greater than RP. That means if you stand on north pole, the radius is less. If the radius is less, earth is pulling you more strongly. And if you are on where? Indonesia or Ecuador in Africa, then the radius is more. So earth is pulling you less force. So where should you buy gold? Ecuador, not at pole. Because you add more gold, still the vessel will bend slowly. Because earth is not pulling it strongly. हर किसी चीज में साइंस है ना? ये हंस रहा है वहां से बैठ के, क्योंकि इसके बाद तो इसकी नौटंकी होगी ना. ठीक है, समझ में आया? ये 9.81. तो आज यहां तक रोकेंगे, लेकिन अब रोकेंगे बोलते किताब बंद मत करो, सुनो पहले. So far we studied about force between two bodies. बहुत सारा लिया हमने, एक्सपेरिमेंट किया. Earth and moon, we did boyfriend girlfriend, we did duck and ant. Last में we tried to see what is the force, because we are at the end selfish. We want to see everything that is happening on earth. So gravitation से आ गए हम gravity में, अपने घर पे आ गए. And रेस्टोरेंट का नूडल्स बहुत खा लिया, अभी घर का नूडल्स है. So we want to see what is the force exerted by earth on a body of 1 kg kept on its surface. So we take its mass, take the mass of the earth, 6 into 10⁻24, distance of separation is 6400 kilometers. पूरा चीज, ये सब आपको कोई एग्जाम में नहीं पूछेगा. Nobody is going to ask you these questions, okay, these calculations. But from here we find out that a body of mass 1 kg experiences a pull of 9.18 Newton. देख आदित्य, यहां से भी कुछ सीखने का है. इसका मास सिर्फ 1 kg, आपका मास 55 kg लिया था, फिर भी पुल कितना आया था? -20. क्योंकि तुम्हारे ऑपोजिट साइड में वो 37 kg की लड़की थी, यहाँ पे कितना है? 6 into 10⁻24 का अर्थ है. भैंसा, तुम इस पर अट्रैक्ट नहीं होगे. कैसी दिखती है, मोटी सी, हाँ है ना, पसंद नहीं. पर अट्रैक्शन तो है. देखो काफी ज्यादा अट्रैक्शन है. 9 पॉइंट किधर गया? 8.8. हाँ, इसे भी मिला था. अब जो नौकरी कर रहा है हमसे पढ़ के जाके, वो भी एग्जाम्पल पढ़ के गया. अभी उसके लाइफ में अट्रैक्शन हो गया, शादी भी हो गया होगा उसका. ठीक है, फर्स्ट ईयर ऑफ मैरिज यू नो इज एवरीथिंग इज व्हाट? सूरजमुखी, चंद्रमुखी. देन एज द वाइफ गेट्स ओल्ड इट बिकम्स सूरजमुखी, थोड़ा टेम्परेचर आना शुरू हुआ. थर्ड ईयर से इट्स ज्वालामुखी, वोल्केनो, है ना. मॉरल ऑफ द स्टोरी, पहले साल जब हम बातें करते, सिर्फ हम बात करते, कोई नहीं सुनता है. उसके बाद से हम चुप रहते हैं, बातें करते हैं, दुनिया सुनती है, बर्तन फेंकते हैं. ठीक है, तो यहाँ आज कहानी खत्म करेंगे. विल एंड आवर स्टोरी हियर. ऑनलाइन एनी क्वेश्चन? सुधृति, Aparna, Sanvi, so far. So as we meet in our next class, we should know what is the generic formula for Newton's law of force of gravitation, and we should also know how much is a force experienced by a 1 kg, because we will need this data. We'll need this data again. How much is a force experienced by a 1 kg body as kept on the surface of the earth, by the distance of separation? These data, nobody will ask you these questions, but you should know. ठीक है, right?